will help you understand kinematics in one dimension. Recall that the most important part is realizing that physics is not about formulas, it's about logic, reason, and common. The final position of an object is given by the initial position plus velocity times time, initial velocity. We also know that the final velocity of the object is given by the initial velocity plus the acceleration times time, and that the final velocity squared is equal to the initial velocity squared plus 2 times the acceleration times displacement. These formulas, you should know when to use them, but most important, you should identify why is it that they are the ones that will help you. Recall that formulas without logic or reason are worth nothing. Now, according to the situation depicted in this exercise, you have an electron which is first accelerating. After it accelerates for a given period of time, the electron is going to be drifting at constant velocity, and finally the electron will come to rest. So pretty much if you have something like this, say this is the velocity for the electron and this is the time, you have an electron that is first accelerating, meaning that the velocity is increasing at a constant rate. Then it is going to drift at constant velocity, so the velocity will remain constant for a given period of time. And at the end, the electron is going to deaccelerate until it comes to rest. So according to this little graph that I just did, the problem should be divided in 3 parts. This is going to be the first part, in which the electron is going to be accelerating. A second part, which is going to be this one, in which the electron is going to be traveling at a constant speed. And a third part, in which the electron is going to be deaccelerating. For each part, pretty much, you gotta understand the same situation, do the same things, and at the end, well, we'll see what is it that we have to do. So for the first part, right, we have an electron which is at rest, meaning that the initial velocity for the electron will be 0 meters per second. We also know, according to the information given in the problem, that the electron is going to accelerate. So we have a constant acceleration, which is going to be 5.33 times 10 power 12 meters per second squared. This is an S. Okay, all of those meters per second squared. So as the electron accelerates, the speed is going to start increasing. And we know that the time for which the electron is going to be accelerating is going to be 0.15 microseconds. Recall that we always need to work in SI units, so this will be the same thing as 0.15 times 10 to the negative 6 seconds. This is because of the prefix micro. I hope you already know that micro implies 10 to the negative 6. Anyway, in the exercise, it is given the equivalence between microseconds and seconds. So, according to the information we have, we are most likely to be using, I believe, this formula, right? The second one. We have the information for the initial velocity, the acceleration, and the time. Having said so, we could find the final velocity of the electron in this first period. So the final velocity is going to be given by the initial velocity, which is going to be 0, plus the acceleration, which is going to be 5.33 times 10 power 12, right, times the time. The time, as we said, was 0.15 times 10 to the negative 6. So now you take that, you plug it into your calculator, which I hope you already know how to use. Let me see what we get. So the final velocity of the electron after this first part is 7 799,500, which is pretty much meters per second, right? So that's the final velocity for the first part of the journey. Anyway, final velocity is not the question. The question is going to be the displacement. But notice that in order for us to find the displacement, given that there was an acceleration, we're going to be using the third formula listed right here. We know the final velocity, we know the initial velocity, we know the acceleration, and well, 2 is a number, so it's not going to be a problem. So now you take all of those, so you say that the final velocity squared is going to be equal to the initial velocity squared plus 2 times the acceleration times the displacement. Final velocity, we just found that, so it's 799,500 squared. Initial velocity, well, that's 0. Plus 2 times the acceleration which is 5.33 times 10 power 12 meters per second squared, times the displacement, which is this one here, is actually the one that we are trying to find. So let me keep going right here. So I'll take an arrow from this point all the way up here. Be sure that this is what we're gonna continue the exercise. Now, well, you gotta solve for this equation, so you end up with 799,500 squared being equal to, well, 0 squared, which is going to be 0, 2 times 5.33 times 10 power 12, and the change in x. So solving for the change in x, which is what we are trying to find, it's the displacement, we have 799,500 squared divided by 2 times 5.33 times 10 power 12. Now you take all of this, you plug it into your calculator, and you should come to the displacement of the electron in this first period of time. So according to what I just did, the displacement will be 0.0597 meters. Anyway, the question asks for the total displacement in centimeters. So now you multiply times 100, and this will be 5.97 centimeters. So as for the first part of the exercise, let me use a color here. This is our first result, the displacement for the first part of the journey. Now, we're gonna use this data that we just got for the second part of the journey, right? So in the second part of the journey, we have an electron, which is traveling at constant speed, because it says it is drifting with a constant velocity, meaning that we know the initial velocity for this part of the journey. The initial velocity here will be the same as the final velocity for the first journey, which is 799,500 meters per second. We also know that the electron is going to be drifting for a period of 2 microseconds. That is given in the statement, as you can see. So we need to find the distance traveled, meaning that in this case, the formula that we're gonna be using, I believe that you all agree, should be this one, right? The very first one. So we can say something like final velocity is equal to final position is equal to initial position plus initial velocity times time. You can take this final minus initial, and you will recognize that this part here is the change in position, which is what we're trying to find, is equal to the initial velocity, which is 799,500, times the time in seconds. Recall to use this in seconds, or else you'll get a very different number. So now you take that, you plug it into your calculators once again, times 0.2 microseconds, and you should all come to say that the distance is 0.1599 meters. Again, we are trying to find the distance in centimeters, so you multiply by 100 to get 15.99 centimeters. So this is the distance traveled in the second part of the journey, in which the electron was drifting at a constant velocity. Now, what we're going to do is do it for the third part of the journey. Third part of the journey is a part in which the electron is deaccelerating. So we know for sure that the final velocity at the end of this journey, well, since the electron will come to rest, should be 0 meters per second. The initial velocity should be the same as the initial or the final velocity for the second journey, since it was drifting at constant velocity, so it should be 799,500 meters per second. We are also told that for this part of the trip, or the journey as you want to call it, the acceleration is negative 2.67 times 10 power 13 meters per second squared. It's negative because the electron is coming to rest, so it's like, picture it as braking. So we pretty much know everything. Again, the equation that we are going to be using should be that the final velocity squared is equal to the initial velocity squared plus 2 times the acceleration times displacement. And recall that what we are trying to find is the displacement. So you plug in your numbers after figuring out that you have pretty much everything. So final velocity squared is equal to the initial velocity squared plus 2 times the acceleration. Notice that in this situation the acceleration, and let me point that out again, is negative times 10 power 13 times the displacement. So you will come to say that negative 799,500 squared is equal to negative 2 times 2.67 times 10 to the 13 delta x. So you solve for delta x, negative 799,500 squared divided by negative 2 times 2.67 10 power 13. So negative and negative, they cross out to give you a positive number, which should be what we expect, right? You plug in those numbers again into your calculator. Hopefully you will do it correct. And you should come to say that the distance traveled in this was 0.023 to 4 meters. Again, the question asks for the distance traveled in centimeters, so you multiply it by 100 to get 2.4 centimeters. Right, and this is the final result. So at the end, the question was the total distance traveled. Total distance. So the total distance should be the sum of the distance traveled in each direction, right? So you will be taking the 597 that we have here, this one, and you should be taking this one, right? So you start adding those results, plus the one we just got, this one. So you add all of those, and you should come to say that the total distance traveled by this electron was 24.36 centimeters. And that's it. Thank you for watching. Hope this helps. See you later.